Hello, can everyone hear me? I hope you can hear me. You have to unmute yourself and say yes if you can hear me. Okay, fine. So what we will do in this class is we'll begin a preparation for IOQM. You guys must have already been preparing. What we'll do right now is solve problems. So a lot of questions will be discussed in this course. The course will be like a 2 month long course. Today is 7th of July, exam is on 8th of September. So I'll try to do as many classes as possible. You can join in and we'll do problem solving in these classes. What you have to do is attempt all the problems and try it yourself. Like if you don't get it, obviously I'll try and solve it during the class for you. However, you need to try it yourself also at home and go back to the videos if you didn't understand something. The recorded videos will be available on YouTube on my channel. So that's it. Like the questions will basically be at IOQM or slightly higher level, but not very difficult. And the questions will be mixed. So we will discuss all the topics, number theory, algebra, combinatorics, and geometry. And we should begin now. So you have to attempt the question. As I stated, you need to try it, and then I'll give you some time to attempt. And then once you have attempted it, you can tell me your ideas and we can discuss the solution. So the first problem is this one. Find the last two digits of the number 7 power 8 power 9. You need to mute yourself. Like there is background noise, Amit. Yeah. Mute yourself if there is background noise. You need to try the question. If you have something to say or discuss about the solution, tell me. So this is the first problem. Find the last two digits of this number. If anybody has any idea, you can share with me. The hint here is think about 7 power 4. What is 7 power 4? Think about that. That should give you a hint on how to approach this problem.
1.
7 power 4 is 2401. So technically, if you think about 2401, that is equal to 1 congruent to 1 mod 100. When I say last two digits of a number, what you need to find is the remainder when this number is divided by 100. We need to calculate 7 power 8 power 9 mod 100. That will give us the remainder, right?
It's 1.
If you have something to say it. Don't have to hesitate. Is anybody getting any answer for this? You can type in the chat or you can speak out loud if anybody is getting any answer. If you don't get any answer, I will tell you what to do. So don't have to worry. Vikas, are you getting something? Okay. So I will tell you what to do. So 7 power 4 is 2401 and that is 1 mod 100. So what we need to think about is this number 8 power 9. 8 power 9 is like 8 into 8, 9 times. So obviously you should realize that this number is divisible by 4. Right. So 8 power 9 is divisible by 4. So it can be written as 4 times k, where k is an integer, right? If it can be written as 4 times k, what can we say? This number is like 7 power 4k, right? Because 8 power 9 can be written as 4k. And now this can be written as 7 power 4 whole power k. And now we know that 7 power 4 was 1 mod 100. 7 power 4 was what? 2401. So the number that we need is 2401 power k, right? Now this is a property of congruence. Like if you have a number x, which is x is congruent to a mod p, then you can show that x power k will be congruent to a power k mod p. This is a property of congruence. Right now, what we have is 7 power 4 is congruent to 1 mod 100. So 7 power 4k would be congruent to 1 power k mod 100. So the answer for us would be finally it is 1 mod 100. The overall number is coming out to be congruent to 1 mod 100. Why? Because 7 power 4 was 1 mod 100 and the overall number is 7 power 4k. So it will be 1 power k, which is same as 1 mod 100. So that means the remainder, when we divide this number by 100, should be 1. So therefore, the last two digits of this number will be 0, 1. These are the last two digits of 7 power 8 power 9. I hope everybody is understanding what we are doing. If you understand, you can say yes or whatever in the chat. Some people already gave the right answer, I think. I hope everybody has understood. If there is any doubt, tell me. Otherwise, we'll move on to the next question. Okay. It seems like there is no doubt for this one. Second question is this. There is a keyboard. A keyboard displays the letters of the English alphabet. Letters of the English alphabet only. The keyboard only has letters of the English alphabet. A cat jumps on the keyboard, and presses 4 different keys. Presses 4 different keys. What is the probability? What is the probability that it pressed at least one of the 4 keys, the keys M, E, O, or W? The question is asking what is the probability that it pressed at least one of the keys M, E, O, and W. The cat has jumped on the keyboard. It has pressed 4 different keys, and you have to find this probability. This is a very common idea. This is a standard method of counting. You should be able to attempt this. I will tell you the hint is complementary counting. So what you should do here is find the probability that cat does not press any of these 4 keys. If you can find this probability that the cat does not press any of these 4 keys, what we can do is we can subtract it from total probability minus this P. Let's say this was P. Total probability minus P would be the probability that it pressed at least one of these keys. Nine by 11, somebody is saying. 9 by 11 is not correct. Think about it. Why are you saying 9 by 11? There are how many letters in the alphabet? 26 letters, no? What is the probability that the cat does not press any of the keys? Any of the 4 keys? Think about that. The cat is pressing 4 keys. So there are 4 things that are happening, 4 events that are happening. Okay. So probability that cat does not press any of M, E, O, W. So think about it. When the first key was pressed, what is the probability that the cat does not press any of these 4? For the first key, then for the second key, third, and fourth. Each of them is an independent event, right? Or there are 4 events happening in succession. You can see for the first key, if you don't press these 4, you have how many choices? You have 22 by 26, right? This is 22 by 26. Then you press a different one, and then you still can't press these 4. The cat first presses one key. It has to be anything other than MEOW. So it has to be 22 by 26 probability. Then if you press any other key except these 4, the probability will be now 21 by 25. You have to tell me if you understand this step. How the second step it is 21 by 25. I hope everyone is understanding how it became 22 by 26 for the first key and 21 by 25 for the second key. For the third key, it will become 20 by 24. And the fourth key, it will become 19 by 23. Is everyone understanding what I'm saying right now? If you don't understand, you can tell me. You can talk in Hindi also if you don't understand, if you want to express yourself in Hindi or something. Okay. One of you says it is clear. Basically, 4 times you are pressing the keys. Every time you have to avoid these 4 letters. So first time it is 22 by 26. After that, there are 25 total letters because you have already pressed one key. But out of 25, again, you cannot press these 4. So it will be 21 by 25. Then it will be 20 by 24 and then 19 by 23. This is the probability that the cat does not press any of this. The answer would be total probability 1 minus this probability. Total probability is 1 and 1 minus this would be your answer. Now this number you have to simplify a little bit. Like when you simplify and calculate it, you'll come close to 0.51. You should check this yourself. The answer is pretty easy to get once you get the idea of how to calculate the probability and how to do complementary counting. So complementary counting is the trick here, right? Okay, if that is clear, I will move on to the next problem. The recording of this video will be available to you later. So if you are stuck, you can look at it again and think about it, right? I will move to the next problem. This is problem 3. This says find the greatest integer n such that 5 power n times n factorial ends in at most 100 zeros. Find the greatest integer n so that this number 5 power n times n factorial ends in maximum 100 zeros. So basically you have to make sure that this number ends in less than equal to 100 zeros. Try to think about this. Let's try to think of some small numbers first, right? If n is equal to 2, what is this? 5 square into 2 factorial. So that is 25 into 2, 50. So it ends in how many zeros? 1 0. If n is equal to 4, think about it. 5 power 4 into 4 factorial. 4 factorial is 24. 5 and 24 into you have 625, right? So this will probably end in 2 zeros. Let's see. You can multiply it and find out, right? 24 into this 0, 0, 2, 5, 0, 0, 5, 12. So you're seeing it is ending in 3 zeros. I hope everybody is getting the sense of what is happening. So as you increase n, as I increase n, the number of zeros at the end will also increase, right? It is obvious that the number of zeros at the end will increase as I increase n. What you have to find is what is the n, what is the highest n, such that it ends in less than or equal to 100 zeros. I hope the problem is clear to everyone. Is the question clear to everyone? Think about it. You should realize that how do you get a 0? You get a 0 when you have a multiplication of a 2 and a 5, right? Every time there is a 2 power 1 and a 5 power 1 in the prime factorization of a number, then you get a 0, right? So in order to count the number of zeros, what you have to count is in this number, how many 2s are there and how many 5s are there, right? The lower number, if the number of twos was 200 and the number of fives is 150, then there will be 150 zeros. I hope you understand what I'm saying. The lower number out of the twos and the fives will be the number of zeros. You have to tell me if there is any doubt, if anything you don't understand. Does anyone have any idea what to do here? I will give you some hints. So, how do you count? How do you count the number of twos in, let's say, n factorial? N factorial is basically n into n minus 1 into n minus 2, 2 into 1. How many twos are there in this? The way to count this is to calculate this number. It is n factorial n by 2 plus n by 2 square plus n by 2 cube and so on till n by some 2 power k, where 2 power k plus 1 will be bigger than n. And what I mean by these symbols is this is greatest integer less than or equal to, greatest integer function. So what do I mean by this? So think about it. Suppose I have to find the number of twos in 6 factorial, right? 6 factorial is 720, by the way. So I can do it directly also, and I will check now the formula here, right? So how to find the number of twos in 6 factorial? I will do 6 by 2 GIF plus 6 by 2 square. And notice that 2 cube is 8, which is bigger. So I don't have to write that. Basically 6 by 2 cube, GIF will be 0, right? So this becomes what? 6 by 2, this is 3 plus 6 by 4, this is 1.5 plus 0 and all the other terms after this become 0. So the answer for us is GIF of 3 is 3 and GIF of 1.5 is 1. So there must be 4 twos in 6 factorial. Now think about it, 720, if you do the prime factorization, you will get 6 into 120. So 6 into 20 and 20 is 2 into 5 into 2. And notice that 6 will give us 2 more 2's. So it will be 2 power 4, 3 square and 5 power 1. See how we are getting the correct 4 answer by our formula also. How do you count the number of twos in n factorial? So this is the expression. This can be generalized also. Count the number of primes p in n factorial. The general expression is n by p GIF plus n by p square plus n by p cube and so on till n by p power k, where p power k plus 1 should be bigger than n. So after that, the terms will vanish because GIF will be 0. This is the way to count how many primes are there in n factorial. I hope everybody is understanding what I'm saying. Right. So for this number, our number was what? Our number was 5 power n into n factorial, right? We have to count how many digits, how many zeros will come at the end, right? So think about it. The number of twos in this number will be same as number of twos in simply n factorial, right? Because 5 power n doesn't contribute any twos. 5 power n doesn't give us any twos, right? Because it is just 5. So the number of twos in this number is the same as the number of twos in n factorial. Correct? And what you should realize is number of fives in 5 power n factorial will be n plus number of fives in n factorial. Right? The number of fives in this number would be n because n comes from here and the number of fives in n factorial, right? Hopefully you are understanding what I'm saying. The number of twos in this number is the same as number of twos in n factorial. The number of fives in this number is n plus number of fives in n factorial, right? Now, if you try calculating, let's find how many how many twos are there. Let's take n as some big number. Let's take n as some big number. We want to have 100 zeros, right? Close to 100 zeros. So let's try something. Let's try n is equal to 100. So I want to count number of twos in 5 power n into n factorial, right? Now this should be equal to number of twos in n factorial. We have understood that, and therefore that will come by doing this formula. N is 100, so it will be 100 by 2 GIF plus 100 by 2 square plus 100 by 2 cube plus 100 by 2 power 4 plus 100 by 2 power 5 plus 100 by 2 power 6. 2 power 7 is 128. So after that, we don't need to do, right? So notice that this will give us what? 50 plus, this is 100 by 4, 25 plus, this will be what? 100 by 8. 8 will give us 12, 12 point something. So GIF becomes 12 plus this is 16. So 16, 6 are 96 plus this is 32. So plus 3 and then this is 64. So only 1 will come from here. So we are getting what? 75 plus 12, 87 plus 6, 93 plus 3, 96, 97. 97 twos will come in 5 power n into n factorial if n is 100, right? And let's count the number of fives. How many fives will appear here? Let's count that. How many fives appear? Number of fives in 5 power n into n factorial is equal to n plus number of fives in n factorial. But notice that if n is 100, the number of fives is automatically 100 plus something, right? The number of fives is greater than 100. Can you see that the number of fives is coming bigger than the number of twos? Number of fives is greater than number of twos. Usually that is not the case. Usually that is not the case. If you have a higher prime number, the exponent will be lesser. But in this case, because we have a 5 power n into n factorial, the number of fives is bigger than the number of twos. for n is equal to 100. I hope you are following what I'm saying. Yes, somebody is saying there is more 5 than 2. That is correct. There is more 5 than 2. In this case, there are more 5s than 2s. So if we want to count the number of zeros, obviously it is enough to count the number of 2s, right? Since there are lesser 2s, the number of zeros will be equal to the number of 2s, not the number of 5s. I hope that is clear to everyone. Yes, somebody is saying 104. So 104 is close to the answer. 104 is close to the answer. The answer is 103. Because when you do 103, you get 98 zeros. So for example, if n is equal to 103, let's count number of 2s. Number of 2s would be 103 by 2 plus 103 by 4 plus 103 by 8 plus 103 by 16 plus 103 by 32 plus 103 by 64. And this comes out to be 51 plus 25 plus 12 plus 6 plus 3 plus 1. And this comes out to be 98. But when you try n is equal to 104, the number of 2s will become, in this case, you will see that the number of 2s is becoming 101. Why? Because you will get 104 by 2 plus 104 by 4 plus 104 and so on. You will get what? You will get 52 plus 26 plus 13 plus 6 plus 3 plus 1. And this adds up to 101. So what we are getting is when n is 104, you are getting 101 2s. And obviously number of 5s is greater than number of 2s. So there will be 101 zeros at the end, right? But for n is 103, you are getting 98 zeros. So the question was saying what? The question was saying find the greatest value of n such that 5 power n into n factorial ends in at most 100 zeros. So you cannot go above 100 zeros. So our answer would be n is equal to 103. I hope it is clear what we have discussed. N is equal to 103 is the answer. The main idea in this problem is to count how many primes are there in any factorial. If you understand how to do that, then after that, everything will become easy in this. You have to realize here that the number of 2s is actually lesser than the number of 5s. So just try it out yourself. You will understand why the answer is 103. Let's go on to the next problem. This is problem 4. And in this problem, you have to evaluate the product. Evaluate the product 1 minus 1 by 2 square minus 1 times 1 minus 1 by 2 cube minus 1 times this goes on 1 minus 1 by 2 power n minus 1. You have to find the answer for this product. This is a very easy question. All of you should be able to do it. So try it out yourself. There is a nice pattern that you will see. If you simplify it correctly, there will be a nice pattern here. So you can easily solve this. Is anybody getting anything? Okay. By now you should have realized that when you simplify this product, you get 2 square minus 1 and 2 square minus 1 minus 1. So this becomes 2 square minus 2 on top by 2 square minus 1. And that can be simplified as 2 common 2 power 1 minus 1 by 2 square minus 1. Similarly, this term, if you see, it will become 2 cube minus 1 by 2 cube minus 1, which is equal to 2 cube minus 2 by 2 cube minus 1, which is 2 times 2 square minus 1 by 2 cube minus 1. So what is special about this? What happens is the terms keep getting cancelled. The numerator of one term cancels the denominator of the previous one. Why? Let's write it like this. You are getting 2 times 2 power 1 minus 1 by 2 square minus 1. And here you are getting 2 times 2 square minus 1 by 2 cube minus 1. So what would have been the next term? If you see the next term, you will get that, right. You are almost right, Amit. Slight mistake is there. Slight mistake. But you're almost right. The next term would have been 2 times 2 cube minus 1 by 2 power 4 minus 1. And similarly, the last term would be 2 times 2 power n minus 1 by 2 power n minus 1. So what is happening is this cancellation keeps happening. This cancellation. So at the end, you will just get this denominator 2 power n minus 1. And on the top, you are multiplying 2. But what the mistake that you made is you didn't count it correctly. There are n minus 1 terms, not n terms. If you see the brackets, there are n minus 1 brackets. So the top is 2 power n minus 1. It is not 2 power n, it is 2 power n minus 1 at the top, right? This is a pretty simple question. Everybody should be able to do it. We will move on to the next one. Problem 5. This question says, find all triples PQR of primes. So PQR are prime numbers such that this equation is satisfied. PQR product is equal to P plus Q plus R plus 2015. Find all the triples PQR of primes such that PQR is equal to P plus Q plus R plus 2015. So think about this. One thing I can tell you as a hint is you can assume that P is less than Q is less than R. The three prime numbers could be in any order. We can always assume that P is the smallest one, Q is the middle one, and R is the largest one. Think about what you will do here. The solution will be easy if you think about the even or odd nature, which is known as thinking about parity. Think about the even and odd nature on both the sides of the equation. That will help you reduce the question, make the question easier. What is the even or odd nature or parity of a prime number? What do you think prime numbers will be? Correct. Somebody is saying P must be 2. Why is he saying P is equal to 2? Because if the prime numbers are all bigger than 2, if P is also bigger than 2, right? Then 2 is the only even prime number. All the prime numbers above 2 are always odd. And if you have all the three prime numbers are odd, then the right hand side is the sum of 4 odd numbers. So that will be even, whereas left hand side will be 3 odd numbers product, and this will be odd. So odd cannot be equal to even, so that is impossible. So all the three prime numbers cannot be odd. So one of them has to be even. Which one will be even? The smallest one. And the only even prime number is 2. Therefore, P is 2. So that is correct. So the equation can now be changed and looks like this. So you have basically 2QR is equal to Q plus R plus 2017. This is the new equation that we have now. We have to think about this and try to find the possible values of prime numbers Q and R that satisfy this equation. We will discuss it on the next screen. So we have 2QR is equal to Q plus R plus 2017. And at this stage, I would like you to know something. This is something that I have discussed in my Olympiad algebra course, which is there on Udemy. This is known as Simon's favorite factoring trick. Factoring trick. So anytime you have a K times PQ plus P plus Q, something like this, then you can add and subtract a constant in order to factorize it properly. So right now we have what? QR here and Q and R also. We can add and subtract some number to factor it nicely. So I will show you how to do that. So for example, here, if I multiply by 2 on both sides, you will get what? This situation, right? We get a situation like this. 4QR is equal to 2Q plus 2R plus 4034. What I will do is bring everything on one side. The Q's and the R's on one side, 4034 here. Now the trick is, if you add and subtract a 1 here, you will be able to factorize the left hand side. So what I'll do is 4QR minus 2Q minus 2R plus 1. So I should also subtract the minus 1, but that is the same thing as adding plus 1 on the other side. This is the factorization trick, that you can add a constant, subtract a constant in order to factorize expressions like this. Now see here, you can take 2Q common, it is 2R minus 1, and minus 1 common, 2R minus 1 is equal to 4035. And therefore we get 2Q minus 1 times 2R minus 1 is equal to 4035. This is my equation, which is now much easier to solve, because we can prime factorize 4035, and that comes out to be 3 into 5 into 269. You can check that yourself. These are the prime factors. So we have 2Q minus 1 times 2R minus 1 is equal to this, right? So now we just take different cases and we solve for Q and R. Remember that Q was less than R. That was our initial assumption. So when we do cases, we have to take cases where Q comes lower than R, right? So what I will do is, you can take the case 3, 2Q minus 1 is 3, and 2R minus 1 is 5 times 269, which is basically 1345. So this is one possibility. And from here, you get Q is coming out to be 2 and R is coming out to be 1346 by 2. So that is 673, right? You could also take the situation 2Q minus 1 is 5 and 2R minus 1 is 3 times 269. And this becomes 5 and this becomes basically 807. And in this case, the solution Q is coming out to be 3 and R is coming out to be 808 by 2. Notice that this becomes 808 by 2, 404. So this is not a solution because this is not a prime number. So this is not an appropriate solution. 673 was a prime number, right? The final case is 2Q minus 1 is 5. No, 15, because 3 into 5. And 2R minus 1 is 269. And in this case, we get Q is 8, again, not a possibility, not a solution, because 8 is not a prime. So the only options for us is this. Q is 2, R is 673, and we already got P is 2. So P is 2, Q is 2, R is 673. This is one possible option for us. And this was the option when we assumed that P is less than Q is less than R, right? So obviously the triples, when we do triples, we can do any order. This was an assumption, so it could be 2, 673, 2 also. And it could be 673, 2, 2 also. I hope you are understanding that there are 3 possible triples that we are getting. The other cases were not working out because we didn't get prime numbers there. The main idea in the problem was the factorizing and then taking cases. I hope that is clear to everyone. If there is a doubt, you need to ask me. You can ask whatever doubt you have if you don't understand something. What? I couldn't hear you. You have to speak up.
Sir, I have done it in another way.
What is the other way?
Sir, can
Okay, I cannot hear you, Joe. Mic is not working very well.
What's
You can send me the solution on WhatsApp later. You send me a picture of what you have done. I'll tell you whether it is right or wrong. But did you understand what we did?
Yes.
Okay. So as long as you understand what we did, it's fine. The next problem, I will just write the problem. This will be homework. Try it yourself. We'll discuss it in tomorrow's class. So this is the problem. Find all pairs m, n of positive integers satisfying the system of equations GCD of m comma n is equal to m minus 12 and LCM of m comma n is equal to 4n minus 12. So you have to find all the pairs of positive integers which satisfy these two equations. Okay. So that question is homework. Actually, I'll give you one more problem. P6 and P7 are homework. We will discuss these two questions tomorrow and start the discussion from here. This problem is find all triples x, y, z of real numbers such that 2x square plus 3y square plus 6z square is equal to 2 times x plus y plus z minus 1. So this is another problem. These two questions, try it yourself. If you get it, great. We'll discuss it tomorrow. So tomorrow's class will start with P6 and P7. Okay. That's it for now. If you have any doubts, make sure that you keep them ready for tomorrow's class. We'll discuss any doubts tomorrow and we'll do more problems. So the first few weeks of the course, we'll be doing problems from different sources for all the topics. Towards the end of the course, second half of the course or second month, what we'll be doing is many problems from previous year's IOQM and RMOs. So we'll do some previous year's questions towards the second month. The first month will be mostly like problems that I will be sending you. Okay. That's it for this class. Tomorrow, same time, we'll do the session. And the recording for this will be available on the channel. So you can check out the video on the channel and see if you have anything that is a doubt that you can watch again. Everyone understands, right?
I have doubt.
What doubt?
Sir, what is the remainder when we divide the of 1 by 1?
Yeah, I cannot hear you. Your mic is not working. You have to change your mic or check your mic and all. If you have a doubt, just send it on WhatsApp because I can't hear you properly. Like there is a lot of background noise or something. Just send your doubt on WhatsApp and all. We'll see what is there. Okay. Fine. I will discuss tomorrow, same time. The class will begin tomorrow. That's it for now. I'll see you next time.